Let us start our next session, allylic bromination. We have actually studied about alkenes earlier, that is alkenes undergo electrophilic addition reactions. So, when bromine is added to an alkene, we get the addition product as shown here. We also studied about the substitution reaction that is carried out under radical intermediates. Basically, when propane is reacted with bromine, we end up with two types of product. So, this is one of the hydrogen is substituted by the bromine atom. So, this is a substitution reaction which undergoes via radical intermediate. So, these are all the two things we have already studied. Now, we are going to look at very different substrate which has both the double bond and the alkyl unit. So, in this type of substrate, this is called propane, and in this particular system, can we predict the product? Will the reaction undergo via the addition, that means the reaction undergoes on the double bond, or the reaction occurs on the alkyl unit, that means the substitution reaction. So, in this particular session, we will be looking at when we take a system where we have a double bond and an alkyl system, which type of reaction will that substrate undergo. This is what we are going to see now. So, if we run the reaction when propene is treated with the bromine at low temperatures, we end up with the addition product as shown here. And when we run the same reaction at a very high temperature, that is 500 degree centigrade, then we get a substitution product. So, what is the driving force for two different products by changing the temperature? So, let us look at little bit in detail about how the reaction actually proceeds. So, what happens at the high temperature? This is a strange question we will be asking now. So, in this particular system, this is a allyl system we call. So, in this system, the reaction actually proceeds with the halogen radical formation. So, if we go back, whenever there is a double bond, actually the reaction proceeds, addition reaction is the major reaction that proceeds, but at high temperature what we are looking at or what is happening is a substitution reaction. So, that means at high temperature the addition does not take place or what. So, this question comes to our mind. So, when the reaction happens at high temperature, what actually happens is, as per the previous thing, the addition reaction actually happens across the double bond. So, here the formation is a halogen radical. So, once the halogen radical is formed, whether at a low temperature or high temperature, that reacts very efficiently across the double bond, and we end up with the addition product as shown here in this particular diagram. But what happens at a high temperature is the CX bond actually cleaves and we get back the radical. So, this is the equilibrium driven reaction. As you can see, the addition first take place, but the addition again go back to the starting material. So, this is what happens at very high temperature. So, due to which what happens is, by the end of the reaction, when we are looking at all the substitution products are again going back to the starting material. So, we only have the starting material, but on the other hand, when the substitution takes place, what we are ending up with basically the allyl halide as shown here. So, at high temperature the addition reaction actually take place, substitution reaction takes place.